Okay, so this is question number 14 of the nuclear homework booklet. So in question 14 part A, we're asked to simply sketch, using these axes down here, a graph of the neutron number against the proton number for stable nuclei between z equals 0 and z equals 80. We're also asked to show some suitable numerical values on the n-axis. So we need to basically label these axes. So if we've done our revision properly, we know that basically if the proton number goes from 0 to 80, then the neutron number goes from 0 to somewhere in the region of around about 120. So basically each one of these can go up in tens. We don't get any marks for doing that. We simply get marks for drawing this line. So what happens then is we get a nice straight line that goes from 0 to at least 10, but it can go up to 20 to make sure you get your first mark. It then curves like this. So that's the second mark, and the third mark is making sure that when the proton number is 80, this finishes off at somewhere between 110 and 130. So if we put it at 120, we guaranteed that mark. So there are 3 marks. In part B, we're then asked to go back to the graph, and we need to basically show possible positions for nuclides or nuclei that are radioactive that can decay via alpha, beta minus, and beta plus emission. And we're asked to label these as W, X, Y, and Z. Well, for alpha emission, they're really heavy nuclei or really big nuclei with large proton numbers of greater than 60. So the exam board want you to put it about here. They basically say that it's going to be very slightly less or slightly below the line. So it's a good bet to kind of put it just below the line rather than above it. That's better for W. Beta minus is X. So in beta minus, what happens is one of our neutrons changes into a proton. So this neutron, if neutrons change to a proton, they move this way, which means that X has to be above the line. Beta plus emission is exactly the opposite. So that's where a proton changes into a neutron. So to get closer to the line, they'll start over here. The number of protons will go down, the number of neutrons will go up, so they'll go in this direction. So Y has to be below the line. Both of these still have to be close to the line. So the exam board say that you have to be within kind of like one diagonal of a square. So you need to put these letters actually really quite close to the line. But if you do that, you get 1 mark for each of those. In part C, we're then told that an isotope of radon, this thing that's got 86 protons and 222 protons and neutrons altogether, it decays sequentially by emitting alpha particles and beta minus particles. This sequentially basically means it emits an alpha particle and then a beta minus particle and then another alpha particle and then another beta minus particle and so on. So what's happening here is eventually this forms an isotope of lead, which has got 206 protons and neutrons altogether and 82 protons. Now, 4 alpha particles are emitted in this sequence. We're asked to calculate the number of beta minus particles in this sequence. So what could have happened? It could have gone, for example, alpha beta alpha, or it could have gone alpha beta alpha beta. So we're not entirely too sure of the exact number of beta minus particles, but it should be somewhere in the region of about 4. It could be basically 3, 4, or 5. So what we're going to do is basically look at how these numbers change. Well, the top number went from 222 to 206. So that changed by 16 when we just think about what's happening in terms of going from radon to lead. 86 went to 82, so that changed by 4. So that's what actually really happened. If just 4 alpha particles were given out, then the top number would change by 16, but the bottom number would change by 8. So the top number is fine. So 4 alpha particles is fine for the top number, but not for the bottom one. So, but what we know is that every time beta minus particles are given out, basically it adds 1 back from when we take away these from our alpha particles. So therefore, because this differs by 4 beta particles must have been emitted. Now, for your 2 marks, you basically have to show what happens with the alpha particles and then finally what happens with the beta particles and show that there were only 4 beta particles emitted. And finally, for question D, we're then told that one particular nuclide is described as being proton rich. In other words, it's basically got more protons than it should have. We're simply asked to discuss, or basically write down, two ways in which the nuclide may decay. When it says discuss, it basically means give some details of. Now, there are two ways that this can happen, really. It can decay via beta plus decay, and we simply explain what happens in that case. In this case, basically, the proton number decreases by 1, and the neutron number increases by 1, because a proton changes into a neutron and it emits a beta plus particle and also a neutrino, an electron neutrino. Alternatively, if it doesn't decay via beta plus decay, it can also undergo electron capture. And again, the proton number decreases by 1, the neutron number increases by 1 because an electron from the inner shell is captured by a proton in the nucleus. It converts the proton into a neutron and it emits a neutrino in that process. Now, this was worth 3 marks. Basically, for 3 marks, you had to name the two decays. That basically got you 2 marks. Name the decay and name this interaction. That got you 2 marks, and then an explanation of one of those got you the 3rd mark. So that was question number 14 of the nuclear physics homework booklet.